Hello and welcome to the wolfSSL live webinar, corner webinar with Weston Embedded. I will pass it on to Anthony. He is the wolfSSL software engineer. He will give a company overview.
Hello, everyone, and welcome to this partner webinar with Weston Embedded. My name is Anthony Hugh, and I will be hosting this presentation. Today, we here at wolfSSL are honored to have Yanko and Janos from Weston Embedded here to talk about their integration of wolfSSL into their firmware stack. At the end of this presentation, both Yanko and I will be available for questions. However, in order to more easily coordinate, this presentation has been pre-recorded, so any comments will be handled at the end. But first, I would like to give a brief company overview before we move to the technical presentation. wolfSSL was founded in 2004 by Todd Elska and Larry Stefanik, when they realized there wasn't an open source dual license embedded SSL library available. OpenSSL existed at the time, but there was demand for alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial-style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 50 dedicated employees in 2024, most of which are engineers. This progress is, of course, supported by a strong partner network that we are very proud of, which includes DDCI, STMicro, and RTI, just to name a few. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO-178 support, FIPS certification and a FIPS-ready offering, MQTT up to the version 5 specification, SSH version 2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrappers and JSSE support, and commercial support for curl as well. All of these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. I invite you to follow us on Twitter with the handle @wolfSSL, as well as all our other socials. Also, feel free to email us at facts@wolfSSL.com if you have any additional questions. And now I will give the floor to Janos.
All right, so thank you for joining us in this partner webinar. My name is Janos Magasrevy, and I'm the president and co-founder of Weston Embedded Solutions. We specialize in embedded software, focusing on real-time operating systems and communication stacks. So let me give you a brief overview of our origins here. In 1992, Jan Labrosse, who is a prominent figure in the embedded software industry, created the first version of the highly popular MicroCOS real-time operating system. It was in 1999 that he decided to launch his own venture, offering customers a commercially licensed real-time operating system. This led to the founding of Micrium Inc. Over the years, Micrium expanded its product portfolio beyond just the kernel, adding a TCP/IP stack, a file system, USB device, and host stacks, among others. In 2016, Silicon Labs expressed interest in the company and decided to acquire it. However, in 2020, they made the decision to divest Micrium. After the announcement of Micrium's closure, we, as Micrium engineers since the early 2010s, collectively decided to start Weston Embedded Solutions with the mission of continuing the Micrium legacy of clean, reliable, and trusted embedded software. All right, to talk more about the evolution of our software, let's go over the following diagram. As I previously mentioned, MicroCOS was released in 1992. With Micrium's foundation came MicroCOS 2, the second iteration of MicroCOS and well-known real-time kernel, even used by NASA on their Mars Curiosity rover. In 2008, MicroCOS 3 was released. It was designed to improve but not to replace MicroCOS2. Then Silicon Labs acquired Micrium, and they made modifications to tailor MicroCOS3 to their specific hardware. They call this Micrium OS, and it's available today through their SDKs. In 2020, the Micrium MicroC product line was made open source by Silicon Labs just prior to closing Micrium. This code is now available on GitHub. After that, we decided to create our own commercial fork of the Micrium MicroC products, and we called it Cesium RTOS. Today, every Micrium MicroC product has been enhanced with new features and bug fixes in our own Cesium RTOS product line. Cesium RTOS is indeed the next generation of Micrium MicroC OS software. Here's a high-level view of our Cesium RTOS. It offers two real-time kernels. They are CSOS2 and CSOS3. Both of them have been widely ported to a large number of semiconductor manufacturers. Our communication stacks include CSNet, which we will be talking about further later on this webinar, a USB device, and a USB host stack. And finally, we also offer a FAT file system called CSFS with support for popular storage media such as SD card, NOR and NAND flash, RAM disk, etc. Besides Cesium RTOS, we also offer a pre-certified kernel called Flexible Safety RTOS. This product is made by our partner Embedded Office in Germany and is based on MicroC OS2. It is pre-certified to numerous standards, as you can see in the slide. We also have a self-paced training package with hands-on lab lessons. We are expanding our portfolio with what we call starter packs. As of right now, we have the Xilinx starter package, which can get you up and running quickly with our Cesium RTOS on the latest Xilinx Vitis tools using the Sync 7000, the UltraScale Plus, and the Microblaze boards. The S32K package provides the same out-of-the-box experience as the Xilinx starter package, but on the NXP S32K platform, which is a very popular one in the automotive industry. Later on this year, we plan to add an Altera Area 10 starter pack, as well as an Amazon AWS starter pack. We also offer technical support plans and consulting services as part of our portfolio. Now let's go over some features of our real-time kernels, CSOS2 and CSOS3. They have preemptive multitasking real-time kernels with optional round-robin scheduler in OS3. They're delivered with complete, clean, consistent source code with in-depth documentation in PDF form. They are highly scalable. You can do unlimited number of tasks, priorities, and kernel objects. They have very low interrupt disable time, and they are certifiable for safety-critical applications. Here are some specifications for CSOS2 and CSOS3. For memory footprint, both kernels are compile and runtime configurable. This allows the user to go as low as 6 kilobytes in ROM and 2 kilobytes in RAM. They both have a preemptive multitasking model with an unlimited number of tasks as a feature of OS3. Scheduling can be done in real time with the option of round robin in OS3. They can be configured to do runtime stack checking and avoid stack overflows. They can catch and delete tasks at that return. There's support for thread local storage on the ARM-CC, Cross-Core Embedded Studio, GCC, and IR compilers. You have the option of a constant or dynamic tick rate, which helps in power saving. Calls have timeouts to prevent deadlocks, and interrupt disable time is near zero. Here are some of the kernel services that are available. You have critical sections, event flags, lock and unlock the scheduler, memory partitions, message queues, mutexes, semaphores, software timers, task registers, task suspend and resume, and data queues. Now let's talk about the embedded network stack called CSNet. It supports multiple interfaces and multiple IP addresses per interface. That's called multi-homing. It supports both IPv4 and IPv6. It has a BSD socket API that supports the most popular socket options, featuring a POSIX-like error handling. It is scalable to contain only the required features and minimize memory footprint. And now newly added is the SSL TLS socket option with the wolfSSL. Here are some of the CSNet specifications. It supports a wide array of Ethernet controllers, comes with DHCP client, DNS client, HTTP client and server, FTP client and server, MQTT client, TFTP client and server, SMTP and SNTP clients, and a telnet server. A real-time kernel is required, preferably CSOS2 or 3. Both UDP and TCP are implemented. There's support for IGMPv2, IPv6 multicast, ICMPv6, ARP, and NDP. For network interfaces, it supports Ethernet, Wi-Fi, and loopback. And finally, it has two sets of socket APIs. One is proprietary, and the other one is a standard BSD socket with support for POSIX like ERNO handling. To give you a sneak peek of what's coming in our roadmap, we have row sockets, Modbus over TCP, TCP cubic congestion control, quick transport protocol, HTTP2 or 3, DHCP v6, MDNS client. Here's where you can reach us directly. You can visit westonembedded.com, actually weston-embedded.com. You can send us an email to sales@weston-embedded.com or simply give us a call at 954-655-2048. We are located in Weston, Florida on the US Eastern Time Zone. Here are some of our partners and distributors. Obviously, we have our newest partner, wolfSSL, Embedded Office, who has been a long-time partner since the Micrium days. They are located in Germany. We are part of the partner programs for NXP, ST, Xilinx, and IR. And for distributors, we have BMR in China, Ruby Embedded in India, SiteSys in Israel, SwiftAct in Egypt. And we are currently working on expanding our distributors in Asia with potentially 2 new distributors coming soon. And now I hand it over to Anthony to talk about TLS.
Hi, this is Anthony again. Yeah, so you know, when we talk about wolfSSL, we talk about TLS, SSH, various protocols. This integration with Weston Embedded is for TLS only. Notably, both TLS 1.2 and 1.3 are available. In terms of our specialty, our niche, you might say, or what we tout, we're very small. When you build wolfSSL with just what you need, you can get it down to definitely under 100 kilobytes without issue. That's because we have many configuration macros where you can turn on and off features that you need or don't need. For example, if you're going to be implementing a client, you can actually disable all server only code to make it a much smaller client. If you're not doing mutual authentication, you can turn off all on the client side. You can turn off any code to do with signing. So that would be a really big win in terms of sizing. Our runtime memory is minimal. When you compare us against something like OpenSSL, it's not even a comparison. It's totally different. So I had mentioned about the configuration flags we have. They're great. We have our FIPS 140-2 certification, and we're on the cusp of getting our 140-3 certification. If you're looking for any kind of revocation, we support OCSP as well as CRL. We support any hashing function that you could imagine, as well as all the stream ciphers and AES modes. The AES modes are really important depending on your application and how you use them. Our public key options are, you know, are all the standard ones that are used in all the protocols. More notably, we also support the post-quantum ones. So we have post-quantum support for dilithium, Kyber. We're bringing in LMS soon, but we already have XMSS as well. And those are basically through our integration with various open source implementations. But at the protocol levels and at the certificate levels, we have support for those. So now I'll be giving it back to Yanko. I'll be giving it to Yanko from Weston Embedded for the technical aspect of the presentation about Weston Embedded.
Thanks, Anthony. As Janos said before, CSNet is the successor to MicroC TCP/IP. We here at Weston Embedded made it a priority to keep its modular design, offering the same API and network applications as its predecessor, but with the added benefit of having more features, continued development, and active maintenance. In fact, since the commercial fork occurred in 2020, CSNet has seen 10 releases that have corrected bugs and addressed serious vulnerabilities found both in-house and reported by cybersecurity agencies. We've also added new features like comprehensive ERNO support, like Janos mentioned, for our customer base who are accustomed to BSD socket programming, providing more descriptive and more usable error handling than like what IP can provide, for example. We have also added the option to use the new Reno algorithm for improved recovery after congestion events subside in network environments with long round trip times, which would benefit those applications that communicate over the internet, such as, let's say, firmware upgrade over the air and other IoT applications. We also support both our CSOS2 and OS3 kernels through our kernel abstraction layer, as Janos mentioned. So users with existing MicroC OS2 and MicroC OS3 applications can migrate to Cesium with no downtime. Another exciting new feature is what we're talking about here today. It's the recently introduced wolfSSL integration, which will be the subject of the demo I'll do in a few minutes. As you can see in this diagram, this is how our network applications interact with the TCP/IP core, and how a TLS stack such as wolfSSL fits into this model, acting as middleware between the transport layer and the application layer. So the way wolfSSL interacts with a TCP/IP stack is through callback functions, which perform the I/O operations that ultimately send the encrypted data on the wire. So here on the left, usually if you want to open a socket, the application will just call the network stack to open the socket and then hand it over to wolfSSL for encryption. If you want to send, receive, or accept or connect that socket to another peer. And this setup works great in many use cases. However, it has a major disadvantage when using an RTOS. That is that the function call stack can grow significantly from where it starts in the upper application level until it reaches the Ethernet driver level. So if you can see here on the right, this is how traditionally MicroC TCP/IP has done things, just starting off with, let's say, a network app like FTP, and then it just sends the request over the MicroC TCP/IP core, and then down to a TLS port like wolfSSL. But it's all done in the same stack frame, the same call stack. So that eventually adds up and can lead to stack overflows. And that's one of the issues that we're trying to prevent or avoid with this port. It's, if you have a single threaded application or a single task in a multi-threaded environment, this is less impactful. But with a more complex application that leverages multiple protocols in several kernel tasks, for instance, let's say a task that uses HTTP, or one that uses MQTT or FTP or a local TCP client, etc., these tasks would each need to have sufficient stack space to accommodate the combined call stack of your application, plus CSNet, plus wolfSSL, which altogether at times can reach upwards of 30 functions deep. And like I said, can potentially lead to stack overflows. Instead of having to set aside this many resources on a per task basis, we created an internal task that takes care of synchronizing access to the wolfSSL library. After compile time configurations, one only needs to flag a socket as secure, install the required TLS certificates or keys, and CSNet leaves the wolfSSL port to do the rest. wolfSSL is mostly abstracted for connecting, accepting, sending, and receiving operations. So programmers need only interface with our NetSoc API or BSD compatible API as they normally would. The port acts as a gatekeeper for network applications and user applications alike, managing their access to the wolfSSL library by forcing them to request an operation and to wait for the result. This allows us to run these type of applications on small footprint MCUs that normally wouldn't be able to handle the previous requirements due to memory constraints. That means that, for example, we can secure 5 sockets on the, let's say, on an STM32H743 device used for this demo, which has 512 kilobytes of RAM, 1 megabyte of ROM, and we can do this with room left for the rest of the application design, thanks to this design and to wolfSSL's ability to pare down to the features we need. The network applications that have TLS support at this moment are HTTP client and server, MQTT client, and FTP client. And we expect to support future network products as well. This is an example of a multi-threaded application that features MQTT client and HTTP server. The client sends out published messages to the broker, and HTTP server sends or serves a dynamic web page to a browser on the local network. As you can see, the number of stack entries remain in the 1 to 2K range, while the wolfSSL internal task at this snapshot is using 45% of its 24K stack size. The wolfSSL internal task avoids having to earmark 2 task stacks of 24K entries each for MQTT client and HTTP server tasks. In this case, that's 192 kilobytes that would otherwise have been required in order to realize the same multi-threaded application without this port. Think about it. That's roughly 37% of the total RAM in this STM32H7 device, just to have these tasks perform cryptographic operations. That's RAM that can be dedicated to the application to do other things, which I believe is beneficial if you're trying to make the complex applications have as much RAM left to it as possible. So in terms of development environment, we like IAR here in-house. It's our tool of choice, but we work with other IDEs as well. So the one thing that is required for wolfSSL to get built is this macro here. This is a symbol that we have to set on the compiler settings for IAR. That basically tells wolfSSL to expect a user settings.h file, where it finds all the compile time macros to configure it and build. These are the configuration parameters in CSNet that are relevant to security. On the left, we have the definitions as they appear in netconfig.h, which is our main config file. In the middle, shown in bold, we have the corresponding wolfSSL settings that get modified in user settings.h. The advantage of this configuration scheme is that it reduces the guesswork of determining which wolfSSL features will be supported by the underlying network stack. We start off with the default user settings.h that we believe should be adequate for many applications, but can then be modified to suit your application if necessary. We have published an application note that describes configuration and best practices in more detail, and it's available on our website. We'll be sure to include link in the description. Demo time. Okay, so what we have here is the IAR embedded workbench for ARM, and it's running our example project, which is an HTTP client example that essentially just contacts or requests, does a GET request for our cesium-dev.com webpage that we host for testing purposes. And it's just going to output that to the terminal here in IAR over and over and over again. after having established the TLS 1.3 handshake. Okay, so I'm going to run it, and then I'll show you the necessary API calls that are being made in order to make this happen. So let's run it. It's acquiring a DHCP address. Okay, so this is our IP address, and it does an NTP request to get the time, and it's just using that as a timestamp to output the web page ad infinitum, just over and over again. And that's the demo. But there's a lot going on from the time that the DHCP address is acquired to what you're seeing here on the screen. Of course, you start with the three-way handshake for TCP, and on top of that, the TLS 1.3 handshake occurs once, and this GET request gets repeated over and over and over again. Let me show you what are the steps required for getting this to work. So first of all, we need to start the HTTP client with this sample function here, definition. Okay, so the first thing that needs to happen is install the certificate. So I'm installing the Starfield root certificate since we're hosting it on AWS. This is the certificate for the page that we're hosting. And we have to specify which format this certificate is in. So if you take a quick look at this, it looks like this, essentially. It's this base64 encoded certificate here. We also have the ability of installing it in DER format. All you have to do is point it to this version of the certificate. They're the same data, it's just encoded differently. And specify here, instead of format PEM, put format DER, and the port takes care of contacting wolfSSL and installing the certificate that way. Okay, so there's different callbacks and the like that the HTTP client supports. So right now we have a persistent connection going, setting this persistent connection parameter here. And that avoids having to disconnect and reconnect, which it becomes costly at the time of renegotiating the TLS handshake. So that's why this is so smooth here. Otherwise, you would see a disconnection and reconnection happening. So we also have this option to set the ALPN TLS extension here. So that's another feature that we added recently to our stack. And that couldn't happen with microCTCP IP. It doesn't have the ability to do this. And then we just open the connection with this API, the HTTP con open, setting the keep interval socket option here. And then the main function here, this is a task that I created, which is the request task that you see here. It's just sending this HTTP app server request, and then outputting to the screen whether it failed or succeeded. Again, just having a request counter here and the date time string that I'm outputting here in the terminal window. So going back, sorry, let me see here. Okay, so going back to the server request, we also setting different parameters here to modify how the HTTP client handles the connection and disconnection events, and what happens when you receive the body of the HTML. And we're also setting a user agent here as well in order to tell the server who we are, for example. And then, yeah, that's about it. At the end here, you just send a request over and over and over again. And that's how you see what you're seeing here on the screen. Okay, so this is the configuration file that I was explaining before. This is our main configuration file for the CSNet stack. This is netconfig.h. So if you scroll down to the bottom here, there's a section dedicated to security, and this is where you find all those macros. This one is especially just enables or initializes wolfSSL in this case. This enables any BSP functions required to enable a hardware crypto engine, like an random number generator, for example. And then also the user settings.h in wolfSSL would have the required definitions for, let's say, an STM32 RNG or crypt or hash IPs. You also have this mutual auth client enabled, which enables the mutual authentication for clients. And right here, this, if you set this to, let's say, 5 or whatever value you want to give it here, it just tells wolfSSL, it tells our stack how many server sockets it can handle. And there's other stuff here as well for the debug mode, for example, and the number of CAs that you can actually install. So that's summarized in the table that I showed earlier. But having this here will have an effect on the user settings.h file that we provide here. This is basically the amount of RAM that you're giving wolfSSL and wolfcrypt. You can redefine it from these values. How do you install cipher suites? Well, you can delimit this string here. Right now, these are the 2 cipher suites that I'm using for this example, but you can add a colon and then expand on this string if you want to support more. And yeah, we have other definitions here for how the memory is distributed, and basically how just telling wolfSSL how to handle memory. These are all these default pound defines that we have here. If you want to enable TLS 1.3 as this project does, you just have to change this here and then enable this. Otherwise, TLS 1.2 is the default if this is redefined to 0. And then we have other definitions here to reduce our footprint and fit in as many MCUs as possible. So yeah, that's basically it. We do have, again, we have an application note that explains this in more detail, and the decisions as to why these numbers are the way they are and all that good stuff. So we have that available in our website, and we'll have a link in the description. Thank you.
That's the end of the presentation. We will now move to the Q&A session. So there is a question: can OS2 or OS3 run on Raspberry Pi single board computer as bare metal firmware?
Yes, the Raspberry Pi actually has the Cortex-A architecture. So yes, both OS2 and OS3 support the architecture. Now, there are real-time operating systems, so it will not be bare metal. You'll have at least a minimum of 1 task running. So essentially, you could make a single task be similar to like a super loop, pretty much. So that, yeah, to answer your question, yes.
There's another question: do you support dual-core architectures like Raspberry Pico dual-core ARM Cortex M0? What communication primitives can be used for communication between tasks on different cores?
When it comes to multi-core, we have to run the Cesium RTOS on each core individually. So we don't have symmetric multiprocessing. Although we've done some asymmetric multiprocessing before, I think it's on a Xilinx platforms. We use OpenAMP. So that's something we can work on if it's asymmetric. Now for symmetric, we're considering developing a new product that supports multiple cores. So the answer to the question is not right now.
Okay. And there's another question: how CS2 or CS3 is comparable with ThreadX when it can be preferable to use CS2 or CS3?
Well, from a technical point of view, in this day and age, pretty much every RTOS covers the same functions. You know, you get the semaphores, you get all the services. Now the difference is gonna come in how when you have an issue, who's there to answer you? You know, we'll be there immediately. You have direct access to our engineers. So one is open source, that's ThreadX. I think Microsoft made it open source recently. So you'll get what you pay for. Again, as soon as you have an issue, we'll be there to answer. Otherwise, if you go with ThreadX, you're gonna have to go through forums and wait for answer or just try to discover them yourselves. There's also the documentation angle and the code cleanliness. Our code is much easier to read. We have all the comments on the right. The function headers are really extensive, so you get all the explanations of what's going on in the functions right there in front of your eyes. There's also the pedigree that we share with Micrium, so it's been certified to numerous standards. It's gone to Mars, so there's really a history here in terms of robustness and reliability.
Okay. And also there's a question, not question, but I'm so sorry for the inconvenience for the resolution of the demo was not great. The recording will be available on YouTube. It should have more visible. You guys can see more clearly on the demo. So please check the recordings. Thank you. And there's another question. How large a certificate or private key can be? Can it be, for example, 100 kilobytes and needs more memory?
Yeah, for that, we have a configurable value in netconfig.h. I understand you couldn't see it in what was shown here in the demo, but you can make it as large as you need to, so long as you have memory. It's just you define it somewhere in your project in a header file or something like that, and then you configure it to be, I don't know, 100 kilobytes or whatever you need on our netconfig.h.
There's another question. How many parallel HTTPS session can be supported on a microcontroller? Like on demo STM32 with 500 KB RAM?
Yeah, so the demo has enough RAM configured for up to 4 connections. So that value is configurable. You can increase it to as many kilobytes as you need. But of course, it's a function of how many, the number of the amount of RAM that you set aside for wolfSSL and wolfCrypt, that will depend on how many sockets you wish to secure. So like I said, the demo is set for 4, but it could be as much as you can with the amount of memory that you have available.
Then there's another question. What recovery steps are possible when firmware based on CS2 or CS3 detected stack overflow? Can it be reboot or else?
We in CSOS3, there's a mechanism that we call the stack red zone, where you can configure how close to the end of the stack is your threshold, So when it hits that threshold, you fall into an exception, a CPU exception, and there you can do whatever you want. You can reset, you can suspend tasks. I mean, it's all up to the user at that point. And that's only on CSOS3. CSOS2 doesn't have that mechanism.
And there's another question. What processor features are most helpful to reduce the RAM footprint needed to support TLS?
Oh, for this, I would say a crypto engine, a hardware crypto engine for sure, because what that allows you to do is you offload all the software implementation of these algorithms into hardware, and you do not need the RAM that would be required to support those algorithms. So I think that's it. That's the main feature that a processor could have that would reduce the footprint.
Okay, there's another question. Why should we pick Cesium RTOS instead of FreeRTOS?
Well, I mean, like I said before, for the ThreadX question, I mean, the main reason will be our customer support. When you buy a license from us, you get the direct access to our engineers. We don't put you through the forums or any long threads to figure out an answer. You can just simply, pick up the phone, call us, or use our help desk system. Besides the support, again, there's the documentation, which is a lot cleaner, and also the code. It's much easier to follow. So yeah, we also, I know FreeRTOS doesn't have, too many stacks, but we also have the network stack like you saw during the webinar. We also have a file system and a USB device and host stacks. Those are all part of the Cesium RTOS offering.
There's another question. What is the price for Cesium RTOS?
So it starts for the basic, just the kernel, it's $8,000, and then it varies on how the software is going to be deployed. So the base price is $8,000. Now you're probably wondering about the network stack. That's $12,000. So if you buy the two, you get $20,000 in total to begin with.
And there's another question. Does the wolfSSL port use dynamic memory with malloc and free?
No, we opted to go with static memory allocation because wolfSSL actually has this facility, the ability to set aside a static array with what they call memory buckets, which are different segments basically of this array, and then that allows us to treat it basically as a memory pool and be deterministic. We do this in order to prevent fragmentation or avoid fragmentation, which is a real problem for embedded systems. So we usually try to stick to using memory pools instead of malloc and free. So that's the route we went with.
And I do have a last question. Is DTLS supported?
Oh, DTLS from the outset will not be supported, unfortunately, because that would require us to basically go and make some modifications to our stack, particularly how we handle UDP sockets. So that is coming. That's a forthcoming feature. So stay tuned.
And actually, there was another question. Does the wolfSSL have STM32 hardware crypto engine support?
I believe they do. Anthony, I don't know if you want to jump in here
Yeah, I can answer that, and the answer is yeah. Yes, wolfSSL has a great relationship with the ST Micro, and every time we talk with them on a regular basis, and we have amazing support for any of their crypto engines and any of their crypto hardware. So yeah, you can it's all if you're using us straight up, we can we enable that through the what is it, the STM32Cube IDE. We have in their IDE we have ways of turning that on in the UI.
There's another question. Does Cesium support secure file system as a part of the FS module?
If the question is about encryption, no. I think the only feature that we have that would be somewhat related is their journaling module, where you could, save your file system in case of power failures and things like that. But there's no encryption going on in CSFS.
Okay, so I'll close the Q&A, and if you guys still have a question, please email us. And thank you, Anthony, Janos, and Yanko for hosting an informative webinar. And thank you everybody for joining the webinar today. And please don't forget to follow us on Twitter at wolfSSL and at Weston Embedded, as well as our socials. Thank you again, and see you next week.